course outcome of this module. Okay, let us discuss about DC motor. So DC motor, it is a direct current motor. It converts the electrical energy into mechanical energy. Of course, already we are studying this is generalized information. This is not a statement. It is generalized information. That is a DC motor is the motor which is going to convert our electrical energy into mechanical energy using the DC supply. In direct current motor, it is a fairly simple electric motor that is uses the electricity and the magnetic field to produce the torque which turns the rotor or the hence give the mechanical work. Okay, this is the thing. Okay, introduction. The DC machines are two type, namely DC generators and DC motor. In that we are going to study already we have studied the DC generators elaborately. In this module we are going to study the DC motor. Okay, so in the DC motor, it is understand the operating principles of DC motor. It is necessary to understand how does the current carrying conductor experience the force when it is kept in the magnetic field. That is our, of course, our principal operation of a DC motor, that is electromagnetic induction, and the Faraday's law of electromagnetic induction. Okay, that means that whenever we have a current carrying conductor, suppose that should be placed in the magnetic field, in the conductor will experience the force. This statement is given by the Faraday's. As per that Faraday's law of electromagnetic induction, in which direction the current will move, the current force will be acted on the conductor. Okay, to understand that concept, we must recall the Fleming left-hand rule. We can say Fleming left-hand thumb rule. Okay, whatever it may be, both will be the same. So we are going to suppose we are going to place the current carrying conductor in the place in the magnetic field. The conductor will experience the force. That what this is the statement. Okay, our objective is in which direction the force will be acted on the conductor. Okay, that is very, very important. For that we got to search out your left hand finger, right hand to, I mean right angle to each other. That is the middle finger and then thumb and then index finger. Okay, one to each other. It should be right. It should be right angle to each other. Okay, so thumb and then index finger should be right angle, and then index finger and then your middle finger should be it should be a right angle. Okay, 90-degree in between. So suppose you search out like that, then we have to give the two important input for a motor. It is a two input input you have to give. One is a magnetic field, another one is a current carrying conductor. Okay, so this is the input. So in the as per this diagram, your magnetic field, it should be, okay, this is the magnetic field from N to S. It should be magnetic lines of forces will be acted. So that will be going to understand by the your index finger. So as per the direction of the index finger, your magnetic lines of forces will be acted on the conductor. So okay, so in this current, in this directions, your current will be passes through. That means this is the conductor. In the conductor, this is the current. Current I passes through. This is current I. Okay, so these two will be the input. Okay, index finger and then middle finger. Suppose this should be input. Once you are given your machine is satisfied these two input, then in the conductor will experience the force. The force should be such a way that in the direction of your thumb. Okay, this is the way. So this conductor will be move upward. Okay, this is a very, very basic thing. We have to understand. We have to recall before we are going to study the principal operation of DC motor. I think now you are very clear about the Fleming left-hand rule. This is the rule which is applicable for any DC motor or any motor, which is the which we have to understand the direction of the conductor or direction of the armature. Diagram of the conductor in the sense direction of the arm. This is the one conductor placed in the magnetic field. Suppose the n number of conductor placed in the magnetic field. So suppose all the conductors will have the same directions of force in the same direction. Then there will be a cumulative force will be added together. So it will be going to run continuously. Whenever you are going to give the continuous current, then continuous magnetic field exists. Suppose these two will be applicable, then your conductor will be move inside your magnetic field. So how the force on the current carrying conductor will be acted? Force on the current carrying conductor, how it should be acted? So if a straight conductor is placed in the magnetic field, it will produce the permanent magnet then the current flow through a conductor, it is anti-clockwise direction. This is very important. Okay, so due to the presence of a two magnetic field, one is current carrying conductor magnetic flux linces, another one is the magnetic field. Okay, these two will be the two input to any motor. Okay, I will repeat. First one is the flux linces, which is developed by N and S magnet, and then another one is the current carrying conductor. In the any current carrying conductor, it should be, suppose it's carrying the current, then in around the conductor there will be a magnetic line. Suppose, I mean, that flux will be developed around the conductor. So now in the field, in the field there will be a two magnetic forces will be there. So due to the presence of two magnetic field simultaneously, the interaction between them, it takes place in the shown in the figure. So this is the magnet, S and N and S magnet. It is a okay, it is a present. So this is the N and S magnet. So from N to S there will be magnetic lines of forces. Then this is the conductor. This this is the conductor. In the conductor, suppose current is flow through from observer to inside the machine. So now you have to recall here right hand grip rule. Okay, you can think that your thumb direction is away from you. Okay, away from you. That means you see your remaining fingers. What is the direction? As per right hand grip rule, in the clockwise direction there will be a flux linces. Now it will be very easy to understand. There will be a two magnetic field exist inside your your field. Okay, in this area, these two magnetic flux linces will be there. One is due to the permanent magnet, there is a main field flux linces. Another one is a flux linces developed by the current carrying conductor. So now these two flux linces will be interacted together. Okay, so what will happen? Already we are discussed that in the properties of magnetic flux linces, already we are discussed. Okay, what will be the magnetic property of magnetic flux linces? Magnetic flux is always, it is prefer the straight line. Then it is elasticity in nature. Suppose any forces, it will be disturbed. Same like forces, it is suppose disturb the straight line nature of the any flux linces. It is always a try to neutralize that positions or restore the it positions. Okay, these are the various things already we are discussed while we are discussed about the magnetic properties of magnetic lines of forces or flux linces. These are the things already we are studied. Now in the position you got to recall that concept, magnetism concept or fluctuations concept here, to understand how the force will be acted. Okay, how the force, the conductor will be experienced force. Now we can understood from the diagram number 2, the fluctuations it will be like this. Okay, after the current is passes through the conductor, there will be fluctuations around the conductor. These fluctuations will be, suppose in this area, the same directions. Okay, this is like this, top to bottom. The main frequency also top to bottom. What will happen? There will be a crowding of fluctuations in this area. This more amount of fluctuations will be added to it. That means, as per your field theory concept, suppose there will be a fluctuations or there will be a field, suppose in the same direction, so that will be going to add to that. This vector addition of two fluctuations here. So what will happen in the left hand side? Okay, here this is of your current, conductor fluctuations will be opposite to the main field fluctuations. It should be from conductor, the fluctuations should be top to bottom, but your fluctuations in the main, it should be top to bottom again. Okay, here it is in the clockwise direction, here top to bottom. So some quantities of fluctuations will be going to act opposite to each other. So definitely it will be going to cancel, some amount of fluctuations will be cancelled. So what will happen in this area? Some amount of fluctuations will be reduced. The total amount of fluctuations will be reduced. Now this crowding of fluctuations is always try to maintain the straight line, or always try to maintain the your straight line of the it is a path, original path. So now because of crowding, it will have a bend like this. So it is like a stretched rubber band. Okay, once you have a stretched rubber band in your hand, it is always suppose you release any forces on the rubber band, it will be have a straight line path. So it's here also you have to recall the same thing. It is a stretched rubber band. So in this like a stretched rubber band, it is always the force will be acted on the conductor. Okay, so now the conductor is try to move from the left hand side to right hand side in this direction. Okay, in this direction, the conductor try to move because of the crowding of fluxes in the right hand side of the conductor. Okay, this is the how the force will be developed on the single conductor. Okay, the force will be acted on the single conductor, single current carrying conductor. Okay, this is the principle. So once the single conductor is experiencing the force, same like there will be n number of conductor in the armature. So all the conductor, it will be have its own forces on each conductor. So it will be going to cumulatively added together. So there will be a torque will be developed on the armature. Okay. Now the magnitude of the force, what will be the magnitude of the force, what will be the quantity of the force acted on the armature conductor, that also we have to recall. That means the force in the sense F. Okay, how the force will be developed on any conductor, this force. Okay, so we have small formula how the force will be calculated. The magnitude of the force experienced by the current carrying conductor placed in the magnetic field, it is given by BIL Newton. Okay, BIL, B will be the flux density, and then I will be the current flow through the conductor, and L will be the length of the conductor. So the product of BIL Newton will be the force acted on the conductor. Okay, in this way we have to understand how the force will be acted on the conductor. So the direction of the force already we are discussed with the diagram we are discussed. Here only the statement. So the direction of the rotation of the motor depends upon the direction of the force acted on the armature winding and the direction of the force experienced by the conductor, I mean current carrying conductor, given by the Fleming left hand rule. We are studied here. Fleming left hand rule. As per this Fleming left hand rule, how the direction of the current, direction of the armature or direction of the motor will be rotate. So this is the direction of the motor depends upon the direction of the current on the conductor. So the statement of Fleming left hand rule, these are also 2 mark questions. Okay, we have to write the 2 mark questions or some objective type questions. You should not omit this statement. Okay, let us study that statement clearly. It is said that if the first 3 fingers, okay, of your left hand, that is very important. Left hand is very important. We have to recall here. For a generator, it's a right hand rule. For motor, it is a left hand rule. It is very, very important to recall. Every time you have to recall whether it should be left or right. So a generator, it should be right, and then motor, it should be left. All remaining all parameters should be the same. Okay, index finger, it is indication of fluxes. Middle finger is a indication of direction of our current. And then thumb, it is the direction of the mechanical force. It may be motor, suppose it is extracted, or it is a generator, it is given to the machine as an input. Okay, this is a way, but whatever it may be, left hand or right hand rule, motor or generator, the parameter never going to change. So for example, your thumb, it is the mechanical input or mechanical output. And then your index finger, it is the fluxes directions from the magnetic field. Then your middle finger, it is going to indicate the direction of the current. Okay, whether it may be motor, it may be generator. The parameter will be the same in each and every finger. But suppose it is a motor, current carrying conductor, and then magnetic field will be the input. So that basically your thumb will be the force developed direction. The direction of the force developed on the armature. If it is a generator, you can stretch to your fingers in the right hand side. Then the same thing, whatever it may be, you are declared as a motor. The same thing you have to declare here also. That means your input is always to mechanical. Mechanical input you have to give in the armature in the thumb directions, and then your magnetic field is developed as per your index finger. So that the current direction in the armature conductor should be the your index finger, your middle finger direction. So that the parameter will be the same, but the thing is how we are going to apply this left hand rule or right hand rule, or whatever may be the input, what is the output, that you have to clear in your mind. Then only you can able to write the appropriate statement for generator or motor, particularly Fleming left hand or right hand rule. Okay, that's what we are discussing here. Okay, so windings of the DC machines, this is very important. While you're going to study the any DC motor, you have to understand once again the construction of a DC machine. Okay, already we studied the construction of DC machine in our earlier classes. The same thing, never going to change anything. Okay, so the construction of a DC machine is common for DC motor and a DC generator. That is very important. Always you have to keep in your mind there is no difference between the motor and the generator construction wise. So while you are going to construct the DC machine, now we are not going to have a intention to whether it's going to operate as a motor or whether it is going to operate as a generator. We don't know. Okay, as per the requirement, the customer will going to run the machine or will going to use the machine to develop the mechanical force or to develop the electrical energy. Okay, when we can able to use the same machine for a generator or a motor. So that what I try to say is the construction wise there is no difference for a DC motor and a DC generator. Of course, it is both will be the same. So whatever maybe the construction you are studying the DC generator, the same thing you have to recall here. There is no little bit difference. Okay, even though we are going to recall what we are studied as a construction of a DC machine or a DC generator, that we are going to recall here also. Okay, for your refreshing of our constructions, I am going to again once again we are going to have some slides to understand the I mean your construction of a DC motor. So here, here also you have two winding. One is a field winding, armature winding. The field winding, of course, it's going to excited by the DC supply. So it depends upon the DC supply excitation. You have two type of the DC motor. One is separately excited and then self-excited. All will be the same. Then your armature also it is to have a winding as per the armature design in our DC generator, lap winding, wave winding, then parallel path, everything will be the same. That you have to recall here. So after that, before they are going to study the detailed of your construction of various parts, refreshment, you have to understand the simple operation of DC motor. See, already we are discussing, it's a recap of what we are studied up to now. When the current carrying conductor plays in the magnetic field, it experiences the force. That already you have studied. This is the first thing you have to recall. The second thing, in the case of DC motor, the magnetic field is developed. Field is developed by the field current. That is a current flowing in the field winding, and then armature winding plays the role of a current carrying conductor. And then the armature winding experiences the force and start to rotate. That's what we are studied up to now. This is the extraction of or this is the conclusion of what we are studied up to now. So this is again simple diagram how your magnetic field will be acted or developed, and then how the single loop machine will experience the force as per the Fleming Philipson rule. Here also you have the same your armature, then commutator, then brushes. Everything will be the same what you are studied in your generator. The construction of DC machine, already we have studied the same study the construction of DC machine. Just I am going to briefly have a discussion, then you can go for the type of the machines. Here also you have a pole shoes, armature winding, and then yoke. This is called a yoke. Then this is commutator. Then brushes. These are the brushes. Then this is armature. Then this is the construction of a DC machine. So here 6 important parts it will be very essential to understand the construction of DC machine. First one is a yoke, second the field winding, poles, armature, then commutator, brushes, and then bearings, and then gears if it is required. Then carbon brushes, everything. Copper brush or carbon brush, everything we have to understand. First one is a yoke. Already you have studied the same thing. Just you can recall what are you have studied. Yes, in the case of yoke, the DC generator, the same thing. There's no difference. Little bit of difference in the DC motor constructions and then DC generator constructions. Even though we get to recall some important point what you have studied in the yoke, field winding, poles, armature, then a commutator, and then brushes, everything. Okay, I'm told we are not going to study any new construction. The construction what you are studying in the generator, that we are now once again we are going to recall whatever we studied the earlier case. So yoke, it is act as the outer support of the DC motor. It is provide the mechanical support for the poles. Then it provides the protection to the rotating and then other parts of the machines from the moisture and then dust, etc. Yoke is an iron body which provides the path for flex lines. So this is a very important point. Although we are discussing the same thing, we have to recall here also. The yoke is an iron body which provides the path, okay, path in the sense the route, okay, path for the flux to complete the magnetic circuits. It provides the mechanical support for the poles. Then the material used to construct your frame or yoke is the low reluctance material such as the cast iron, silicon steel, or rolled steel, or cast steel. These are the things these are the various materials you have to select for construction of your yoke. Then second part is the pole. So the pole of a DC motor is an electromagnet. The field winding is wound over the pole. The pole produces the magnetic flux when the field winding is excited. The excitation it may be set for separate as per your requirement or as per the construction of DC machine. Selection of DC machine, you can give the separate excitation or the self excitation. Then field winding is a coil wound around the pole are called field coils, and they are connected in series with each other to form the field windings. All the connections, all the field coils should be connected seriously. That is, you have to recall in this moment to understand the field winding. Okay. Then the current passing through the field winding is a magnetic flux produced in the air gap between the poles and armature. So poles and an armature core. And then poles are electromagnet. The field winding is wound over it, which produce the magnetic flux when the field winding is excited. The construction of construction of pole is done using the lamination of a particular shape to reduce the power loss due to the eddy current. This already we have studied. The same thing you have to. The very important point is the construction of pole is done using the lamination of the particular shape. Okay, to reduce the power loss due to the eddy current. Already we have studied the two losses in the DC machine, that is eddy current loss and hysteresis loss in the constant loss category. So to reduce the eddy current losses, we have to select the appropriate lamination in between the various shapes of the armature, laminated sheets. Okay. So pole shoes, the pole shoes is an extended part of the pole due to its typical shape. It enlarges an area of the pole or so that more flux can passes through the air gap to the armature. Materials used to construct your poles the same like low reluctance magnetic materials such as the cast iron, cast steel, or cast iron used for construction of a pole and then pole shoes. So field winding already we have studied, same thing. Field coil wound over the pole, the coil wound in the pole core are called field coils. Field coils are connected in series from the field winding. The current is passed through the field winding is in a specific directions magnetize the poles and then pole shoes. Thus magnetic flux is produced in the air gap between the poles and the pole shoes and armatures. The field winding is also called as the exciting winding. It's a very important point, Field winding is also called exciting windings. Material used for the field winding is a copper winding. Copper coil or aluminum copper winding particularly. The majority of the windings should be in the copper. So due to the current flowing through the field winding, alternate N and S poles will be produced. So armature, of course, what you have studied, in your DC generator, same thing here. Once again, we have to recall. The armature is a cylindrical drum mounted on the shaft in which a number of slots are provided. Armature conductors are placed in these slots. These armature conductors are interconnected from the each winding. Armature windings. The commutator. The commutator is a cylindrical drum mounted on the shaft along with the armature core. That also very important. What you have studied in a commutator in your DC generator, the same thing here also you got to recall. The common statement for the commutator is a mechanical rectifier. It can convert our AC induced EMF to DC current. Likewise, suppose you are given the DC current from the outside to inside. It's a DC motor. It is a supply we have to give from the outside to inside armature. So it will be going to suitably converted into AC current. Okay, reverse vice versa. In the generator, always the EMF induced is that armature is always it is a alternating current, current. That alternating current is always it is going to converted the suitable DC current by the conversion of current by the commutator. Of course, the same it will be going to repeated while you are going to give the DC supply to the armature, input to the armature, your commutator, it will be going to convert a suitable AC supply after commutations. Okay, so that AC supply only we are going to give in the armature conductors. Okay, So that will be going to suitably going to develop the continuous torque on the armature conductors, such a way that your armature will rotate continuously. So it collects the current from the armature conductors and then passes it to the external load via brushes. Okay, the same thing. It is the I mean, it is a conclusion of our armature core. Whatever you studied, no, the same thing. The laminated construction of iron core, it is used to minimize the eddy current losses. Whatever you have studied in your analysis, no, the same thing you have to repeat it here. Materials used for armature core is high permeability, low reluctance cast steel or cast iron materials. It should be used. So armature winding, the same thing. What you are studied, your armature. I mean, your DC generator here also the same thing. I mean, the armature winding, it's a have a, lap winding or a wave winding. Depends upon the current rating and depends upon the voltage rating of the machine. It should be either selected wave winding or lap winding. When that armature winding is rotated using the prime mover, it cuts the magnetic flux lines, and then voltage get induced in the in the conductor. So armature winding is connected to the external circuit load to the commutator and then brushes. So materials used is armature winding. It is supposed to carry the entire load current. Hence, it should be the made up of conducting materials such as the copper. So here only one thing is you have to recall whether suppose it is the motor, it is a supply from outside to inside, outside to inside, we are going to give the supply. If it is generator, it is generated inside the armature, it should be given to the outside to the armature. Okay, this is the current direction. You have to always you have to keep in mind that we are going to study the using circuit symbol of DC motor. So commutator, what you are studying, no, the same thing you have to recall here. It is a cylindrical drum mounted on the shaft along with the armature core. It is made up of a large number of wedge-shaped segments of a hard drawn, copper. So segments are insulated from each other by the thin layer of mica. Okay, this is very important. The mica insulation is very important. Okay, this mica insulation, it's always have a higher amount of mechanical strength than the copper. That also already I'm given on questions in the objective questions in the class assessment test 1. What is the density or what is the mechanical strength of copper brush and the mica? Okay, I am asking the question. I mean, you might maybe recall that questions in the MCQ of class assessment test 1. The armature winding are tapped, at various points, and these tappings are successfully connected to various segments of the commutator. Of course, this is a very important point you have to recall in the DC motor also. The function of commutator. Okay, we are discussing here also. You have to summarize what are up to now you have studied. The conversion converts the AC induced EMF into DC current. Suppose a DC input current into AC current, whatever it means. Vice versa. Okay. Either it suppose it given the input as a AC, it will be output a DC. Suppose input it is a DC, output it should be AC. Likewise, it is a mechanical rectifier. Okay. It is a rectifier in the sense AC to DC or a DC to AC. What does it mean? Converter. So you can say the conversion of. It's okay. You can say converter. So materials used is made up of copper. Then brushes already what you have studied in the generator, the same thing you have to recalculate. The commutator is a rotating part, so it is possible to connect the load directly to it. And the current is conducted from the armature to the external load by the carbon brushes, which are held against the surfaces of the commutator springs. So brushes, it is have two materials. One is the copper, another one is the carbon. Depends upon the requirement. You can go for the carbon or copper. But for the neutralization of the your armature reactions, we should replace your copper brush with a high resistance carbon brush, such a way that you can able to reduce the voltage commutations. Okay. Resistance commutation also we are going to understand whether we are going to use your carbon brush or copper brush. It depends upon the requirement and then voltage rating, and then your commutation process. We have to select either copper or carbon. So the functions of brushes are to collect the current from the commutator and then supply to the external load in the generator, vice versa the motor. Okay. Up to now, what you have studied is what is the principle of DC motor, how the force will be acted on the armature conductors. Then what will be the direction of the rotation of a DC motor, then construction of DC motor. These are the various things we are studied up to now. Now, we have to understand one basic concept of a DC motor. While the DC motor is rotating inside the strong magnetic field, it will be experience the it will be going to develop the mechanical forces on the armature conductors. So, while it is rotating in the strong magnetic field, now the conductor, armature conductor, will experience the fluxes changes in the armature conductors. Okay. Okay. When the armature windings of the DC motor start rotating in the magnetic fluxes, it's produced by the field winding. It cuts the lines of magnetic fluxes. Okay. Each and every armature conductors. Okay. It will be going to cuts the lines of magnetic fluxes. So what will happen? Okay. I think it seems to be a generator principle. Okay. What is the generator principle? Fluxes linking on the conductor changes, EMF will be induced in the conductor. This is the statement for your generator. Okay. Now, so cut the magnetic lines of forces which produced by the field magnet. So what will happen? Here there will be a generator action on the armature conductors. So this generator action or this generator principle which is applicable on the armature conductor, there will be a EMF in the armature conductor. Okay. Still now it is running as a motor, but it is run as a motor. The same armature conductor which is extracted the magnetic forces from the field winding, but the same time your all the field your armature conductor will experience the fluxes changes in it. Okay, because of main field fluxes will be going to cut by the armature conductor because of it is rotating inside your strong magnetic field. So because of the changes of the fluxes in the conductor, there will be a generator action. So this generator action again it is going to induce some quantity of EMF in the armature conductors, even though still now it is run as a motor. Okay, hence according to that Faraday's law of electromagnetic induction, there will be a induced EMF in the armature winding. Okay, so as per the Lenz law, the induced EMF act in the opposite direction to the armature supply voltage. Okay, so armature supply voltage, it is a voltage is given from the outside to inside, outside to the inside to the armature conductors. Now once it is true, then there will be a the motor action. Okay, once the machine is run as a motor, the fluxes on the armature conductor, it's a linking, it will be going to changes as in the generator principle. Now while it is running as the motor, but the fluxes again the fluxes changing on the conductor is it changes simultaneously. So as per the Faraday's law of electromagnetic induction, there will be a EMF on the same conductor. Okay, the direction of the EMF it will be developed inside the armature conductor. It will going to flow towards the supply voltages, direction of supply voltages. Okay, the direction it is as per the Lenz law. So the hence this EMF is called back EMF. Okay, denoted by E suffix B. This is very important. E suffix B. Okay, the equation for the E suffix B, that is back EMF, because it is the EMF developed as the machine is run as the motor. It is also satisfy the generator action. Okay, as per the generator action satisfaction, there will be EMF in the armature conductor, motor armature conductor. Okay, this motor armature conductor will experience the EMF. That EMF will be generated inside the armature. It is act to affect the, or it is going to oppose the supply voltage V. So the voltage induced inside your armature conductor, it is a okay. It is going to oppose the cause producing it. That means your voltage applied from the outside to the machine V. So now the EMF induced in the armature conductor is the back EMF. That is, it will be denoted by EB. So the formula for EB is equal to N into P pi Zn by 60A. Whatever may be the voltage equation you have studied, the back voltage equation you have studied in your generator, the same voltage. There is no difference at all. Okay, the same voltage equation you have studied, you have to recall here also. So EB in the sense the back EMF EB, even though still now it is working as a motor. While it is working as a motor, there will be a generator reaction of the armature conductor. Because of the generator reaction of the armature conductor, there will be a back EMF. That EMF will going to develop inside your armature conductor, and it will going to affect the supply voltage. So because of that Lenz law, it will be going to oppose the supply voltage. So this from the inside to the armature to the outside to the supply voltage, it is the direction is the back direction. I mean backward direction. So it will called back EMF EB. Okay. So the direction of back, I mean the direction of back EMF, it will as per the Lenz law. Okay. Then the equation for the back EMF is P pi Zn by 60A volt. Whatever you are studied in your generator EMF equation, no, the same EMF voltage, same EMF equation, there is no difference at all. Now we are going to have a small brief regarding that back EMF. Okay. When that armature winding of the DC motor is start rotating in the magnetic field, magnetic flux produced by the field winding, it cuts the lines of magnetic fluxes and induce the EMF in the armature winding as per the generator action of the motor. This is a statement for your back EMF is generator action of the motor. Okay, this one line it is enough to understand what is the action of your why the EMF will be induced in the armature winding as in the case of motor. Okay, I am repeated the statement. You can understand the statement easily, or you can memory the statement easily. I am repeat. Please listen carefully. That is generator action of the motor. Still now it is motor, but there will be generator action. Okay, that will be going to, we are state that generator action of the motor, that is a back EMF. Okay, so equation for the back EMF is EB is equal to P pi Zn by 60A volt. Okay, that we have a symbolic representations here. Okay, so this is the motor. The supply it will be given from outside to inside, that is V. This voltage given is V. This voltage generated, no, this is EB. This is EB. So the voltage difference in this, I mean across your armature conductor A1, A2, it is A1, A2. Okay, across that is V minus EB. V minus EB. Okay. V will be the supply voltage. This is the V, armature supply voltage. This is armature supply voltage V. Okay, the V. So back EMF is the EMF developed inside your armature conductor as in the case of generator action of the motor. So here the statement for your EMF equation for the back EMF is P pi Zn by 60A volt. Okay, N will be the speed of the speed in RPM, pi flux per pole, Z number of conductors, P number of poles per pair, number of poles, A area of the cross section of the conductors. Of course, EB is the back EMF. Okay, I think you can understand clearly what do you mean by back EMF. This is for a single understanding or simple understanding. You got to always keep in your mind the generator action of the motor. Okay, this will be going to oppose the direction of the armature supply. This is very important. This point is you have to keep in your mind. The back EMF is always oppose the direction of the armature supply voltage. This line is very important. Okay, so this we are explaining here. This is what we are explaining here. This V, it is the supply voltage. This is the V. Okay, the direction. In this direction, this is the direction